Okay. Hello everyone. Thank you so much for the invitation. It's really nice to be here. So my name is Ziheng from George Mason, and you can call me Jensen. Yeah, I think I became like friends with some of you last night. So it's great. Yeah, I got inspired about this talk actually. So my talk is actually from the perspective of academia, and we think that open science should be like I think Juan mentioned the fear, right? Not yesterday, but we think that it's not enough. It's actually should be more tangible and productive because that's like a two pillars. When you onboarding new people, you have to make sure that they are easy to get on board. It's not like spend another 5 years PhD to get on board, and that's gonna be a disaster. It's never gonna be competitive to exist in the world of AI. So yeah, that's my talk. Something about me is I'm actually a GIS background, but I really like coding and programming. I contribute a lot to open science project, open source project on the GitHub. And I really like AI, but I'm not trained as AI expert. But so that's kind of like my heart, motivation driven. Like I really wish that I can contribute to something in the AI world. And yeah, I'm a long-time open source project contributor. My peak time is 2021. And you can see that basically every day I have some commits to the open source project in that year. Right now I'm working on 3 projects. There's like AI-based Wi-Fi spreading forecasting. That's a LoVa project. AI-based sway prediction. Sway is a sway slow water equivalent. How much water in the snowpack? And that is like an asset project. And which is NASA project is the AI-based ozone estimation, which is already in production based on some like a workflow software we developed. So yeah, that's what I basically working on. My some of my experience tells me that coding is just like a community show. So I just responsible for like writing the code, and the box is kind of like it's just making a joke as punchlines. Anyway, yeah. So I'm not sure about you guys, but I feel my job is on the brink. It's like the AI is coming at us. I heard a lot of voices from my colleagues, especially those people spend like decades of effort in the numerical modeling, doing some like forecasting, but eventually some guy in the corner of the Google headquarters just came up with AI model and just outperform every model existing. So it's kind of like frustrating. And we feel like, our effort is actually some kind of useful, but it's not competitive to the AI. So we think that maybe, well, if you cannot compete with them, join them. So yeah, we think that from long-term perspective, AI proof job is definitely working on AI. So the things that we're working on the data science, as collecting data is actually the first step of the AI job. So yeah, it's not gonna replacing all the jobs, but yeah, it definitely has to like planning ahead. Like, are your job opportunities is like kind of like proof to the AI, the blossom or something in the next like 20 years something. Yeah, we have that kind of anxiety not because like we saw all the news that just spreading all those anxieties. It's like actually there is scientist workshop in the National Academy of Science and Engineer Medicine, and they had this workshop last year, and they say actually this is a consensus about like what AI is gonna do in the science domain. So by 2050, AI expected to be able to do Nobel quality research and write papers. So that is like completely replacing the work of scientists. Most of the time, scientists just working on getting data, do their experiment, and see the result. And that kind of work will be replaced by AI. That is consensus. It's kind of like it's a bunch of very renowned scientists sitting in one room and came to this conclusion. it's really mind-blowing. And you have to just plan ahead about that. And the one barrier that we are experiencing right now is like, what's the difference between our group and OpenAI? Like, what is it? Like, why can't we just train a GPT model and make it operational? Is it like a GPU or expertise or people, technology, software, hardware, or we just don't have time to do it? And like, what is it? Like, I think people should think about it. Actually, all those people in the OpenAI came from academia, and all they know, we know. You know, they have the GPU cluster for sure. But we have it too. It's like we have like high performance computers at NASA. Actually, we can apply and use it. So hardware, software is no problem, and algorithms. It's not more complicated than numerical model algorithms, to be honest. It's like if you get one like modelers right now and have him or her work on the AI algorithms, he will figure it out like in half a year. It's not that hard. The algorithm, the math is not that hard. So what is it? Like preventing us from being the AI innovators. I think everybody should think about it. I kind of have some answer, but I'm not sure, you know, I can persuade you guys. So it's like, but I think we should do this. Like let's democratize AI for science, because science need the open AI, real open AI, not that, you know, the fake open AI. So we should make it decentralized and do it together. And that is most hardest thing, I think. It's like because we are small teams. Even we are like a very big institution like a UMD, George Mason actually the biggest, not just university in Virginia right now. We're still working in silos. You know, we're still working in the small team settings. And we actually, you know, met the concept of decentralized together. And we definitely should work together. It's not like, you know, one team just figure out all at once. It's not gonna happen that way. Because OpenAI is like how many people? Like 3,000 something working together every day. They just working on one pipeline, and everybody just, you know, when there is some issues, they just jump in and fix it together. 3,000 at the same time. Actually, we have an active OpenAI staff member at GMU campus right now, and he's in the cover of assistant professor there, but he actually working on the ChatGPT right now. So what we should do, like science community should tear down the walls and break the, you know, eliminate silos, and we should work together, like in some way, either decentralized or whatever. Like we should bring everybody's effort together and make it into one maybe product. Somebody perhaps say that should be like an industry to do, right? The companies should create that kind of service. But in the world of AI, I think everybody is just in the same track. The academia, the industry, everybody's just in the same track because we are all impacted. So yeah, let's go back to my topic. It's like, you know, what is tangible and productive? I think that's the key to unlock like how to bring people together here. Because if the workflow, like if the AI model or technology is not tangible and people cannot get as productive as the industry, we will never make it. It's like we're always working in that old small team settings. So yeah, I think we have seen like not if it's not like meanings, but it probably just tens of thousands AI papers came out every year. But if you really look into them, you will see that there is like maybe very few of them will come into operation and production. And why is that? It's like somebody just do some AI experiment and drop it and, you know, forget about it because I already have the publication. I can't graduate right now. So there is nobody else care about the result and how to make it practical and operation available to everyone. So this is sadly the reality. It's like the AI academia world is like just publish papers and nothing else. So what's the bottleneck? It's like AI, yeah, as I mentioned, the company has a settings, so they are sharing everything with every member of the company. So once there is a problem, some people just jump out and fix it. And in the academia, it's like you know, somebody just take your workflow and run it on their local machine and find there is a bug and nobody know how to fix it, what we do is just send an email, and maybe we'll never get a response. So that's the difference actually. No one cares about your full stack AI workflow in academia. That's a problem. Yeah, so we are suffering from the low productivity actually because of that. Because of low fairness of the full stack workflow. We don't want just only need your AI models or algorithms. We need all of them, like from the first step, collecting data, to the last step, converting the AI output to the products. We need the whole thing. Like that is called full stack AI workflow. And we need that from the previous person who did that. And if without the full stack model, you only get like AI model weights, and then you spend like another 2 years to figure out how it works. By that time, another new model came out again. So whatever you work on, it's become out of date. It's like your effort is going to the wind. So that is the main problem about our like low productivity. Actually, many people in academia don't want to talk about it, but that's actually the reality. So how to efficiently share workflows and how to fast onboard new people is the key problem, is a key task we should do for open science. Why we are talking about workflows right now? Because workflow is like the chicken will give you the egg. The data is actually the egg, but the workflow is the chicken. It's like a tree. It's like it's easy to like pick the apples from the tree and give it to you, but it's really hard to transplant the tree to your backyard and create that the ecosystem to generate your own apples. So it's very hard. That's actually a key technology bottleneck right now. So we created a software called Geoweaver. Yeah, that's what I'm looking at. It's like, so Geoweaver is actually a handy workflow software that we are using, and its idea was proposed in 2018 and funded by NASA in 2019, funded by NSF in 2020, and NOAA in last year. So yeah, we are actively working on this software. It's complete open source, MIT licensed. Anybody can use it and commercialize it, whatever. We just want to make sure that people, when they are creating their silo workflows, it's shareable and it's instantly reusable, and you can just export the full stack workflow and share with somebody else in no time. It's like, yeah, we believe that will break the walls and eliminate the silos. And we have Python version as well. I'm gonna skip here. Yeah, so it's pretty easy to use. Actually, you can just import that Python Geoweaver and start it. It's actually a web-based application. You can just write your Python code in there, and you can just stop it just like a notebook. I'm not sure if this is a video or not. Yeah, okay. So the difference between Geoweaver and the Jupyter Notebook is, well, those can allow you to execute any code you have, like Python code, shell code, anything. The difference is Geoweaver has a history button. It will record everything you did. Like every time you try to execute your code, it will record the source code and the output. And that is so essential because no one wants their time wasted. Even you're like playing with your code, it's just it's some kind of work. You need to preserve the work and be able to share it. And so if you made some mistakes, somebody else will not make the same mistake again. It's like in our campus, every student just go into the same rabbit hole and just can't get out. And with this Geoweaver is that you can just see all the mistakes that previous students made and just avoid that, just to not execute that kind of code. And you can see that what code will work. That's the difference from the notebooks. And we're also working with NASA OpenScapes and commit the notebook on how to use Geoweaver in their cookbook. NASA dataset cookbook. Actually, how to use the library there to download NASA data and generate your AI workflows. It's pretty easy to use actually, and also we have tutorials on how to use it in HPC. All right, yeah, this is a technical stuff, so I can skip it. We can compare the Geoweaver with other the solutions on the market. We found that there is no other software can do the same thing, basically. Okay, so yeah, some must-have benefits. Actually, I'm not going through all of them. I can just tell you that because we are a small team too, like me and 5 other students and some other collaborators. It's basically the maximum 10 people. But we managed to create 3 AI workflows in the past 2 years using Geoweaver. It's very productive. And we really, really encourage you to use it because it's like onboarding new people, because the students is typically new people. It's like they get on board and go away in 2 years. It's like very rapidly changing. And using Geoweaver, onboarding them is just a 1 week work. It's not like, you have to train them another 2 years to get them on board. By that time, they graduate. So yeah, this is one of the biggest benefits we have. Data management, visualization, extensibility. Yeah, it's all technical. Yeah, anyway, I'm not gonna go into that graph. It's like, yeah, if you go to your client, you have the client, and if you ask them what they want, they have no idea, but they want it tomorrow. That's actually steadily how the AI is actually working right now. It's like nobody knows what's coming next in the AI world, but they want AI right now, and they want to use it. It's something like that. It's kind of similar to what happened 100 years ago. It's like Ford said, if I ask the customers what they want want a faster horse, not a car. That's the same thing in AI right now. So nobody knows what comes next. Anyway, this is the ozone estimation workflow we just did in operation. You can see the AI is actually working. So this is why we are using AI. AI is really works in the Earth sign. Our experience is that every student take only 1 week to onboard, and we have like 5 people maintaining the workflows, and we are pretty productive because of that tool. Because if you want to be productive, you have to have some tool to do it. And Geoweaver is our solution. All right, yeah, let me play this video and let's